What's up guys, this is Massey, welcome to another video. In this video I want to solve some examples regarding vectors and their components. The first example is what are the x component and the y component of a vector A in the xy plane if its direction is 250 degrees counterclockwise from the positive direction of the x-axis and its magnitude is 7.3. So the first thing I need to graph it. It's going to be this one. Something like this here. And it's going to be a graph like this, because this part is going to be 250 degrees counterclockwise, so it goes this way. As you know, it's 180 degrees here, so it means that we are dealing with 70 degrees here and 20 degrees here. And the magnitude of this A is 7.3 meters. Now we want to find out the x component and the y component. So it means that we need to draw two vectors when you project it over the x-axis and the y-axis. So this one is going to be ax, this one is going to be ay. Now if you want to find out ax, you're going to say that this triangle here, you know the magnitude of this length, which if you consider this triangle, that's going to be the hypotenuse. We have 70 degrees and we need to find out the adjacent to this 70 degrees. So we know cosine is adjacent over hypotenuse, and hypotenuse in this case is 7.3. So adjacent, which is the ax, equals to 7.3 cosine 7. That will be 2.5 almost. And now, because we basically calculated 70 degrees, but in reality that is 250, and as you see here, that goes to negative side. So since it's going to negative side, we need to make it negative 2.5 meters. Now let's find out the ay. Ay it's going to be the same length as this vector here, which is going to be opposite. So sine 70 equals to opposite, which is ay, divided by a hypotenuse, which is 7.3. So ay equals to 7.3 sine 7. That will be equal to 6.86 meters. And since it's going down again, you know that's going to be the quadrant 3, and in quadrant 3 we know sine and cosine, both of them are negative. So that's going to be negative 6.86 meters. So ax is negative 2.5 meters, ay is going to be negative 6.86 meters. We could also use this triangle here. In this triangle we have 20 degrees, so in this case ay is going to be the adjacent and ax is going to be the opposite. So you could say ax equals to 7.3 sine 20, ay equals to 7.3 cosine 20. That is going to give you exactly the same numbers in here. Again, it's going to give you positive, but since we need to find out the 250 degrees and it's in quadrant 3, that's going to be negative. So it's going to be negative 2.5 and negative 6.86 meters. So these are the two components of this vector. If you want to check the answer, you need to say that a equals to square root of ax squared plus ay squared. So square root of negative 2.5 squared plus negative 6.86 squared. And when you calculate it, you're going to get 7.3 meters, which is exactly what you have in here. So this is the final answer. This example, we have a displacement vector r in the xy plane is 15 meters long and directed at angle theta equals to 30 degrees. Determine the x and y component of the vector. So here we can say rx equals to r times cosine theta and ry equals to r times sine theta. So it is going to be 15 times cosine 30, 15 times sine 30. So the first one is going to be 13 meters and the second one will be 7.5 meters. In this example it says the x component of a vector A is negative 25 meters and the y component is 40 meters. What is the magnitude of A and what is the angle between the direction of A and the positive direction of x? If you want to find out the magnitude of this vector, you can say A equals to square root of ax squared plus ay squared. So it's going to be square root of negative 25 squared plus 40 squared. Then that will be 625. This one is 1600. And at the end it's going to be 47.2 meters roughly. And if we want to find out the angle between direction of A and the positive direction, we can say that tan theta equals to ay divided by ax, which will be 40 divided by negative 25. That will be negative 1.6. So theta is going to be tan inverse negative 1.6. which will be negative 58 degrees, or here, since the tangent is negative, it means that it has to be on quadrant 2 or quadrant 4. It cannot be on quadrant 4. Why? Because here the ax is negative, so it has to be in quadrant 2. So this one is 58, so the angle is going to be, actually this one is going to be 58, so it's going to be 180 minus 58, which is going to be 122 degrees. So 122 degrees, and the magnitude is going to be 47.2. Now in this example it says a ship sets out to sail to a point 120 kilometers due north, and an unexpected storm blows the ship to the point 100 kilometers due east of its starting point. How far and in what direction must it now sail to reach its original destination? So here we can say that we have 100 kilometers, that's going to be dx, and dy is going to be 120 kilometers. Now it's going to be d will be square root of dx squared plus dy squared. That will be 100 squared plus 120 squared, and that will give us 156 kilometers. Then for the theta, we can say tan inverse of theta. That's going to be 120 divided by 100, which is 1.2. So tan inverse will be, theta is going to be 50.2 degrees. So this is going to be the direction. In this example it says a heavy piece of machinery is raised by sliding it a distance 12.5 meters along a plank oriented at angle 20 degrees to the horizontal. How far is it moved vertically and horizontally? So it is basically something like that. Theta is 20 degrees and the piece moved by 12.5 degrees. So it has to be up to here. 12.5 degrees. So if you want to find out the horizontal distance, you need to have x equals to d times cosine theta, which is 12.5 times cosine 20 degrees. That will make it 11.46 meters. That's the horizontal distance. The vertical distance or height is going to be d times sine theta. So it's going to be 12.5 sine 20 degrees. That make it 4.28 meters.